Great. Thank you so much, Sarah. I'm happy to be here, and I'm actually on the land of the Gubby Gubby or Cubby Cubby people. So I would like to acknowledge them. And yep, today I'll be talking about understanding climate variability in the wet tropics. I'll stop my video as well just to save bandwidth if you want. And look, if I touch on something that you want me to cover more in depth later, please make note of that because I'm happy to do that. So I will be the first to say that I am not an expert on general wet tropic agriculture. So if you have a particular situation that you want me to kind of chat about, I'm happy to do that. I'll just need some input from you on your particular situation. But I'm really good at connecting the dots once I have the information. So without further ado, I will start my presentation.
And Chelsea, feel free to leave your video on. It's great to see you while you're speaking.
Never mind. Okay, I'll leave my video on then. Oh, there we go. Okay.
And can you share your presentation at the same time?
Yep, happy to do that. Although I tend to make jokes and then I'll be like, ha! And I can't see anybody. So
well, I have heard about some interpretive dance. So leave the video on. I want to see about the interpretive dance.
Yeah, so it's always a bit challenging. I remember the first time I did one of these Zooms, like right at the beginning of COVID, it was atrocious. It was terrible. Anyway, yeah, so I'm with the Northern Australia Climate Program. For those of you that haven't heard about us, we're mostly funded by Meat and Livestock Australia, as well as the Queensland Government Drought and Climate Adaptation Program and the University of Southern Queensland. And what's really cool about this program is that it's not just research or it's not just extension, it's actually research, development, and extension. And the importance of that is that when I go out and talk to producers, or when our extension officers, which we call climate mates, go out and talk to producers, we listen, and a producer might say, oh, look, that forecast, the way it's presented, it's terrible, it doesn't make any sense, or, you know, actually, we really need more information like this. And then we take that back to the researchers at the Bureau of Meteorology and the UK Met Office, and essentially give them the feedback, and then they go, yeah, okay, we can actually do something about that, or no, can't really do anything. But I just wanted to point out this lower left corner here, the purple map. That's what we call a burst forecast. And
Chelsea, I don't, can you just try sharing that again? I don't think we can see that yet.
Oh, sorry. Let's, oh yeah, you're right. Excellent. Let's start again. Hang on. You haven't missed much, don't worry. Can you see it now?
Yeah, we can. Thanks.
Oh, okay. There we go. Thank you for pointing that out. There we go. Okay. So, like I said, you didn't miss much. It's just sort of a schematic of what I'm talking about. All right. So bottom left is what we call our burst forecast. And that recently went live on the Bureau of Meteorology website. So essentially it provides a forecast for meaningful rainfall, probably outside of the wet tropics. Most people want to know when they're going to get at least sort of 20, 15, 25, 30 mil or something like that, because so they can plant on it or apply fertilizer or do whatever. I think that we do go up to 75 mils within a 3-day time period for this forecast. So that's kind of like where you guys would be looking. Although you probably want the forecast that says, like, when are we going to have less than 1 millimeter? There actually is that forecast as well. Different story. But yeah, so essentially that product was created because producers told us that they needed to know when they were going to get meaningful rainfall, not just a millimeter or two. Oh boy. And that's switched over there. Okay. Moving on. Oh my gosh. There we go. Okay. So I've been asked to talk, I was originally asked to talk about climate change, and I'm not a climate change person. I do climate variability. And I just wanted to talk about the difference between the two. And actually I will touch on a little bit on climate change. So climate variability is more like the difference from year to year, sometimes even season to season, although it's more of a year to year thing. So like some years are unusually warm, some years are unusually cool, some years are wet, some years are dry. That's climate variability. Most people think about it in a cycle. So you'll usually have a year or two of dry, a year or two of flooding, and then a couple of years where it's sort of in between, and then it kind of comes back around. As they say, every drought in Queensland begins and ends with a flood. So that's sort of reflecting this cycle. For most of Australia, the climate variability is influenced by the El Nino Southern Oscillation, also the Pacific Decadal Oscillation, which I will not be talking about. But if you want more information, definitely feel free to contact me outside of this. Specifically for the wet tropics, it's also really influenced by the Madden-Julian Oscillation, also known as the 30-day wave. 40-day wave or 60-day wave, all different time periods. And cyclones, of course, are a major driver. And then the main way that we know about climate variability ahead of time is through a seasonal forecast. So that's either a 3-month or monthly forecast, which we'll also talk about today. Now that contrasts with climate change, which is long-term. So either decadal or, 100 years, 1,000 years, 1,000,000 years, that's all climate change. And it tends, when we think about climate change, we tend to think about trends. So things are getting warmer, or things are getting colder, or things are getting wetter, or things are getting drier. It's an ongoing trend as opposed to a cycle. Of course, it's due to both natural factors. There's always been climate change. The climate has always been changing. It just, how fast and in what direction and all these different things. And part of that is influenced by human-related factors. I always like to say, the earth will go on. We might die out, it'll kill us off, or we'll kill ourselves off, but the earth will go on. So I don't know, maybe that's the good news of the day. So this is going back to climate variability. This is an example of climate variability. So this is the annual rainfall at Kuranda. And what's shown is the difference from the median. So I essentially took all the years of data, figured out what you get in, what Kuranda gets in 5 out of 10 years or 50 out of 100 years or whatever. And then anything in blue shows an amount greater than that median, and anything in red shows an amount below that median. So the median for Kuranda is 2,040 millimeters from July to June, so the financial year. So we can see here, 2021 was slightly above average, but not, or slightly above median, but not hugely above median. 2020 was okay. 2019 was shambles for everybody. I would guess 2018, that was the Queensland floods. I think that's when it would have shown up on this thing. Yeah, so we can kind of see, there's a bit above the line, a bit below. If anybody remembers 1910, anybody? Yeah, really wet that year. Probably wouldn't want to have lived in Kuranda that year. Or actually more recently, 1978, which was another big year. So almost 3,000 millimeters above already 2,000 millimeters. The cattle would have just been floating away. And then this dark blue line here shows the trend. So over the entire data set, we've actually been trending towards a slight increase of about 300 mils of rain per year. Yeah, I would say any questions on that, but we're not doing questions till the end. But so this is what we're talking about with climate variability. Some years we have more than the median, some years we have less than the median. Some years we have lots less than the median for a number of years in a row. Some years we have a lot more than the median. And how do we manage that? So apologize, it's not your vision. This is slightly blurry, but so now this is climate change. When we talk about climate change, we talk about things like this. So this is trend in total rainfall, annual, and they would have split up the wet season into 2 separate years. So take this with a grain of salt, 1910 to 2020. And we can see for most of the wet tropics, there hasn't been a whole lot of change here, according to this map. This one's slightly better. So December to February, but only 1980 to 2018. So just under about 40 years. And we can see that there's been a slight increase in summer rainfall during that time. And this is millimeters per decade. And finally, this is sort of like the past 20 years, the past 2 decades, and it's been kind of same. Not a huge trend there for this specific area. However, if you were thinking about moving from the wet tropics to southwestern Western Australia. Yeah, really drying out there. There's been a very clear drying signal. I think we can even see it. Oh, not so much in that one, but yeah, not the place to move if you like rain. But maybe you're sick of rain, in which case it would be a good place to move. So in terms of climate change, so this is that long-term thing, specific to the wet tropics, I did a bit of research since, again, it's not my field of expertise. And there's no clear indication of whether it's going to be wetter or drier in the future. There's like some areas like southwest Western Australia, southern Queensland, there's a very clear drying trend that is projected to continue. However, for the wet tropics specifically, there is no clear trend. Some models show drier, some models show wetter, some models show about the same. So at this point, we can't make any really long-term decisions on that information because it's inconclusive. However, the rainfall is projected to become more intense. And this is because warm air and also warmer sea surface temperatures hold more moisture and are more conducive to holding moisture. And so as soon as you have air that can hold more moisture, it tends to create more dramatic events. So thunderstorms, you know, they're huge and they just dump it all at once, as opposed to that nice sort of gentle rainfall that everybody has in their memory, which may or may not have actually existed in the past. But look, what we do know, rainfall is projected to become more intense. So there might not be a change to the overall average, but it'll come more at once. Temperatures everywhere are likely to increase. That's just a thing. You might not notice a huge difference day to day, but it might be like, instead of having, 3 days in a row over 39 or 40, suddenly you now have 5, and then maybe that becomes 8. And then, so it's more things like that. The cyclones are more likely to be intense. This has been shown in model after model, study after study. They're likely to be fewer of them, but when they do come, they're likely to be more intense. Now you might be like, well, the past 2 years haven't really shown that. But again, we have to think about this is long-term, this is climate change. So over the next sort of 50 to 100 years is what it's projected to be. And it comes back to those warmer sea surface temperatures being a bigger moisture draw. They're also going to extend farther south, which means that we can get systems moving farther south, and then the warmer air holding more moisture. So there's just more potential there. But in addition to just more rainfall, the winds are projected to be stronger. So some in the wet tropics and along the coast up there. The storm surge, if you're really close to the coast, the oceans are, sea levels are expected to rise. Again, that has to do with a couple things, but one of them being that warm water expands. So the storm surges will be bigger. And the spatial impact, the cyclones will, because they're stronger, they'll come more inland. So if you thought that you're out of the clear, or maybe now you're sort of in an area that's kind of on the margin of cyclones, in the future, it might reach all the way over to you. Changes to species ranges, that's pretty normal with a changing climate. Especially endemic species that just live in like one little area. I really hope that the cassowaries are able to adapt because I love them. They're like dinosaurs. They're so cool. More pest and disease pressure. I don't know a lot about this, so I couldn't say how much more or what pests. This is just what was in a few different studies that I read. And fire risk is interestingly projected to increase for specifically for the wet tropics. These are all specific for the wet tropics. I don't know why that is, but potentially with more intense cyclones, you'd get more intense blowdowns, which would then die off, and then you could get bigger fires, I guess. And interestingly enough, in a changing climate, we do know that fires are actually going to happen in more sort of rainforesty areas. Like I know Byfield a couple of years ago had a really bad fire that they thought, oh, this is rainforest, it could never happen here. On the southern rim, or whatever it's called down here in southern Queensland, they had that big fire a couple of years ago. So just saying. Okay, I already talked about this. The way the rain falls is changing. Has anybody noticed this? Clearly I can't see your hands. Most people have noticed it already. It's just more to come. And oh yeah, thanks, Sarah. And it just means that there's going to be more runoff, which is potentially more erosion. And the plants might not get the same utilization rate if you crop or plant anything. So just something to be aware of. Yes. Okay, so what can we do about this climate change thing? Again, specifically, I'm talking about climate change. I'll get to climate variability in a minute. So I find anyway that dealing with climate change as like a whole idea is just super overwhelming. And I just go, nope, I can't deal. Nope, I got enough going on in my life. Like that's way down the list of priorities. And that's totally understandable. And I feel like most people feel that way. So what I like to do is think about it in more like bite-sized chunks. So if we're going to have more hot days, and let's say, you're growing tomatoes or some crop up there, and you're already noticing that those hot days are kind of impacting your crop. It's either wilting, or maybe it's getting more sunburned, or it's just having sort of negative effects on it. Maybe now we start thinking about an alternative for that, because it's not going to get any better in the future, as opposed to just holding out hope that someday it'll get better. Probably not. So, having a plan is a good way to go. More intense rain, again, having a plan to maintain ground cover, or maybe looking at your drainage system if you have one, and seeing in those big events that you're currently having, is it capable of dealing with it? And if not, start a long-term budget to install a new drainage plan, or install a new drainage system at some point in the future. Stronger cyclones, if you're thinking about building anything new and you are in a cyclone zone, really look at the standards that are currently available and see if you can just bump it up one. How much more is that going to cost? And just think about budgeting for that again, long-term. So these are all sort of long-term things that we can start thinking about now in little bite-sized pieces that long-term will help us deal with the changing climate. So now let's talk about climate variability, a topic I'm a bit more comfortable with. I'm mainly going to be focusing on seasonal climate forecasts, and essentially it all kind of ties into like an annual management plan. So I won't go too much into that, but I'll tie it back to that. So first off, before we look at any forecasts, it's really important to understand the difference between mean, which is the same as average, and median. So your mean is where you just add up. Let's see. So here, this is from Georgetown, Queensland. It's 20 years of data, so 2000 to 2019. If you add all those totals up and you divide them by 20, your average is 600 mils per year. However, if you instead rank them from lowest to highest in values, so the same data, but just ranked instead of averaged, your median is whichever value is in the middle. So out of 20 years, you actually end up with two values in the middle, and you can just take the average of those or just pick one or the other. It doesn't really make that much of a difference. So the average rainfall is about 600 mils. However, the median is 537, so quite a bit lower. In the tropics, it's not quite so big. We'll actually look at some of the data from the wet tropics specifically, but it's something important to keep in mind, and that's because really large rainfall events, unusually large rainfall events, will skew an average, whereas they won't skew a median. So whenever you're looking at a seasonal forecast, it'll always show it relative to the median. It's just something to be aware of. So here is Port Douglas rainfall data. And we can see, for January, the mean and the median are quite similar. However, for April, they're a bit different, and, kind of in the drier months, they're slightly different. Not that it will make, probably matter that much. But December, 206 is the average. So clearly, occasionally you'll get a big probably cyclone through or some other sort of tropical low starting in December. But generally, it's about 140. So let's quickly talk about seasonal forecasts, and then I'll show a couple live. So seasonal forecasts can help a management plan that is focused at dealing with climate variability. A seasonal forecast is anything sort of longer than the next 2 days, or sorry, not 2 days, 2 weeks. So 2 weeks, 1 month, 3 months. Those are typically now our seasonal forecasts. So this is one for November 2021, and this is from the Balm. And we can see its chance of exceeding median rainfall. So that's why I explained the medians before. So we know exactly, what that is, or we understand the term anyway. And so it's just chance of exceeding median. So we don't know, you know, how much more than the median we're going to get. It doesn't tell us that. It doesn't tell us when in the month of November. It could be any time in the month of November. It could fall any way in the month of November. However, what it's saying is for most of the sort of the wet tropics regions here, there's at least sort of a 70 to 75% chance of exceeding the median. So if we're sitting there and let's see, this was issued on the 7th of October, and we're wondering, you know, do we really kind of need to be proactive about fixing that road before November, or is the wet going to start a bit late and so we can push it off? I kind of look at this and go, okay, well, what is my median? Well, this is for Coranda. The median is 56. But, you know, if I got quite a lot more than that, maybe not. And this is saying there's a good chance that I'll get more than that, or at least that. So maybe I would push forward like a repair or something to my road, or some sort of access, or maybe getting in a wet season lick, anything like that. It turned out November 2021 got 128 mils in Coranda. So just something to be aware of. Now the flip side, so this is what I like to call a wet forecast. It's showing that there's a good chance of exceeding median rainfall. And lots of people see these and they go, oh, it's blue, it means it's going to rain a lot. No, remember, it's always relative to your median. So if your median's really high, then yeah, it's a lot of rain. But in other places, so probably in November, you know, somewhere over here, their median might be like 10 mils or something. That compares to this. This is what I call a dry forecast. And this is essentially saying that you have a very little chance of getting meaningful rainfall, or at least getting your normal median. So, you know, if you're coming out of the drier season for you guys, the drier season, and you're kind of wondering about what decisions you can make on property, if you see this, you know, you're probably not going to get a lot of rain. So this is October to December 2019. Interestingly enough, in November, you only got 6 mils. So the median, or sorry, Coranda got 6 mils. The median again is about 57. So quite a lot below the median. Interestingly enough, the cyclone came through in December and completely skewed this forecast. However, we'll talk about that later. But generally, when I say, if you see a forecast that looks like this, it's all red, this is the one that you want to believe, because they're usually right more often than these. And I like to think it's because predicting 0 rain or very little rain is a lot easier than predicting rain of a certain amount, so exceeding the median. Just my thoughts on it. Okay, so now let's look at some websites. I should have them here. There we go. I went to the wrong page. Oh, this is fun. Sorry, technical difficulties at the moment. Oh boy. Okay, there's that one. Oh, there we go. Okay. Am I still sharing? No, I'm not. There we go. Okay. Great. So this is the Balm homepage. I don't know if anybody uses the Balm. They are getting better. If you haven't used them for a few years, try it again. They're getting better. I go to this climate and past weather. That's where you can find your seasonal forecast. And then the rainfall outlook is where we get our seasonal forecast information. There also is useful stuff over here, especially this climate driver update. It tells us what's going on in our oceans, and like with the El Nino and La Ninas and all of that stuff. So that one's pretty good. And then the tropical climate update is also quite relevant for the wet tropics. But right now, I'm just going to show this chance of above median forecast today. And we'll just see what it says. So the easiest way to have a look around is to click on this little magnifying glass and type in wherever you are. And then you get this handy dandy little box that pops up eventually. Let's look at the month of August here. Okay, so it has all this great information in it, and it's saying, so it tells us our historical median. So the historical median in August at Kuranda is 29 mils. And interestingly enough, it's not showing any clear signal as to whether it's going to be unusually wet or unusually dry or median. It's kind of saying it's probably not going to be unusually dry, but there's also not really a big skew towards unusually wet either at this point. Let's look at our 3-month now. If we look, let's go September to November. So you can just, I'm just clicking on these different timelines at the top. So here's 3 months. And then this box will update. Okay, so now outlook for August to October at Kuranda. So now we can see that there's actually a clear skew towards this decile 9 and 10. Well, what does that mean? Well, if we think back to our median rainfall, where we ordered it from lowest to highest, and we picked the value in the middle as our median, essentially your decile 9 and 10, if instead of picking the value in the median, you looked at the top, the wettest 10 years of data, that would be your decile 9 and 10. Unfortunately, they give you the rainfall values down here at the bottom, so 175 mils. So in 10 out of the past 100 years, the wettest 10 years have had at least 175 mils. And this is showing essentially that there's a pretty good chance of being in that bracket. And there's a very, very good chance that the median will be exceeded. And there's pretty much no chance that the median, that it'll be unusually dry. So look, yes, there are limitations to this forecast, but it provides us with more information than not looking at it at all. So in a minute, when we talk about our plan, I'll tie it back to that. And just for fun, I wanted to look at, this is the European Center for Medium Range Weather Forecasting. I'll put both of these links into the chat box. And sometimes it's just fun to see what other models are saying, seeing if they're all saying the same thing. I'm just toggling around here. Again, if you have questions or if this is really interesting to you and you want more information, please get in touch. I can let you know when we have a workshop in that area, or possibly Terrain wants to do something else. I don't know with this, but so here we have August, September, October. This is Australia. They don't provide all the values for you like the Balm does. So it's kind of good to go look at the Balm first, but it's essentially showing a similar thing. You know, there's a very good chance of being of exceeding median. And the nice thing about this forecast is that it goes out 6 months. So this is September, October, November. Again, the wet tropics is looking like it's going to exceed median. October, November, December starts backing off a little bit. Okay, not too much. It's still, we're still 80 to 90% chance of exceeding median, but it's not quite as that solid green color as before. And then the final one, there we are, November, December, January. Again, the wet tropics are still in this really good chance of exceeding median rainfall. However, large parts of the rest of Australia are not. They're just in the kind of one way or the other box at this point. However, the farther out we go, the less certainty there is with our forecasts. So I wouldn't be like, oh, well, in January, I'm going to do this based on this forecast. This just provides a little bite-sized tidbit of information that I go, oh, okay, like it's saying, you know, we're likely to at least exceed median until probably the end of January. So what does that mean to me? Okay, I'm going to stop that share, reload my PowerPoint, and then keep going with that. There we go. Okay. And so here, there are the websites, but I can't actually copy and paste them when it's sharing, so I'll do it later. So anyway, I wanted to just really quickly talk about realistic and unrealistic expectations of a forecast. They provide general/regional information, not paddock specific information. So, you know, if one person gets all the rain and you don't get any, it doesn't mean the forecast was wrong. It just means that you happen to be in that, you know, area that just happened to not get it. Because the forecasts are always, you know, there's always a percentage chance of something happening, but then there's, you know, so if there's an 80% chance of something happening, there's still a 20% chance that it might not happen. That's how they work. Why is that? And it's because nobody can see the future. Because if we could, we'd all be rich, right? We'd all play the lotto. They're correct about 70% of the time. So if you use seasonal climate forecasts, in 7 out of 10 years, you'll win. In 3 out of 10 years, you're going to lose. It's a risk. But again, we can't see the future. So you just have to take the information and add it to whatever else you're doing and make the best decision possible. That's all anybody can do. Forecasts can be confusing. And so if you don't fully understand it, they can be easy to misinterpret because they're not really intuitive. So just be aware, because if they always seem wrong, it could be an interpretation issue as well. It's all very complicated. And of course, using a forecast is only one piece of information. There's obviously going to be many, many other things that come into any decision that is made. Yeah. So this year, well, the past 2 years and this year will be a La Nina year. I won't go into it right now, but look, it's likely going to be a La Nina year. But now you might be like, well, what does that really mean for me? So in the wet tropics, especially, because you generally get cyclones through that bring through a lot of rain, it's the El Nino Southern Oscillation generally impacts earlier season rainfall rather than sort of January later on when you're more likely to get a cyclone. So it's just something to keep in mind. And here we can see that so this is a Mila Mila. Did I say that right? Mila, I think it's Mila. Anyway, if it's Mila, I apologize.
Mila, you got it
Mila
right.
Mila. Okay, I thought that was right. Great, thank you. So at Mila Mila, in 5 out of 10 years, any 5 out of 10 years, they can expect to get 316 mils between October and December. During El Nino years, so the drier phase, about 250. But during La Ninas, in half of La Nina years, they'll get 450. So this comes back to that, you know, decision thing, like, oh, I know it's going to be a La Nina year. So is there anything I should prioritize because this is more likely to happen? Or, oh, it's an El Nino year. Is there anything that I should prioritize because we're less likely to get that early season rain? So just something to think about. Interestingly enough, 2018 was very much an El Nino year, 820 mils, but it was due to a cyclone. Interestingly enough. This is the kind of looking at the same data, but in a different way from Melanda. This is October to April. And we can see that generally speaking, during La Nina years, they tend to get above their median, which is 1,176 between October and April. And during El Nino years, it's usually below. However, there are a couple when it's above, most likely again due to cyclones. So we can just see so the El Nino Southern Oscillation is the main climate driver for the wet tropics. And this is just showing and demonstrating how having one of those events really shifts the odds one way or another. I'm nearly done because I know I'm a bit over my time and I want to leave enough for questions. But this is a really important concept. So people are like, well, so I'm looking at my seasonal forecast and it's showing I'm going to get a lot of rain. But then, like, you know, when we finally get to that time, we don't actually get the rain. Why is that? And it's because I was trying to figure out a simple way to say this. Prediction lead times are relative to event duration. So we know that the El Nino Southern Oscillation goes for about 6 to 9 months. That's how long an El Nino or La Nina event tends to go for. And so that means that we can predict that event and kind of know which way the odds are going to skew about 6 to 12 months in advance. However, there are other things that operate on shorter time scales that won't be included in that seasonal forecast because they don't exist for 3 to 6 months or 6 to 12 months or whatever it is. So for example, a cyclone only lasts a few days. So we'll only pick those up, you know, a few days before they're formed because they don't exist on a longer time scale. So we can't predict them on a longer time scale. And then, you know, to go even smaller, it's like a little local thunderstorm that has to do with uneven heating of the ground. That uneven heating might only exist for 4 hours. So we can only predict the likely outcome of that 4 hours, you know, before it happens. So that's why it's important to think about, just duration of events and how seasonal forecasts work and why they're different from, let's say, a weather forecast. Happy to clarify on that more if you need it. And yeah, sort of the moral of the story is, if you don't have any idea of what you'd change, if you know it was going to be wetter or drier or hotter or colder, then it doesn't matter because you have nothing to change. So having a plan that incorporates, you know, an action and kind of says, oh, if it's going to be wetter, I'll do this, or I'll be more likely to do this, or you need to have that in order to make this useful. If you don't have a plan, you know, don't waste your time looking at seasonal climate forecasts because they won't really matter. Okay, final slide. So this is a Balm rainfall forecast. They have recently updated them, so this is probably not going to be quite as relevant, but it'll still be relevant for people who use things like Willy Weather or Elders, because they're still shown in this format. So this is a forecast for Innisfail. I always show Innisfail because it always rains in Innisfail. And it's showing on Thursday, the 21st of May, there's 100% chance of rain, and the rainfall range given is 10 to 30 mils. So most people would look at that and go, oh, there's 100% chance of 10 to 30 mils. And then they get 5 mils and they're like, oh, forecast was wrong again. How did they get it so wrong? It's at 100% chance. Well, actually, it's 100% chance of any rain, which is 0.2 millimeters. It's a 50% chance of 10 millimeters and a 25% chance or low chance of 30 millimeters. Now, like if you look on the app on your phone, it'll tell you what I just said. But prior to this update that just only happened like a month or two ago, not even a month, you would have no way to know that. Like there was no way anybody would have intuitively known that it was a chance of 0.2 mils and a 50% chance of the lower value and a 25% chance of the upper value. So now you know. Interestingly enough, on the 21st of May that year, this was a couple of years ago, it rained like 125 mils in Innisfail. Yeah, which I thought was pretty funny. I don't normally tell people that, but because you guys are from the Wet Tropics, I figured you'd appreciate it. So the key points are that if you manage for climate variability, so that's that seasonal or sort of annual cycle, you're going to be managing for climate change as well. If you're making if you're paying attention now, and if you have a plan now, it'll absolutely serve you well into the climate change future. Of course, managing for anything requires that you have a plan. And with climate change, we don't know much about rainfall, except it'll be more intense. Temperatures will get hotter, but what does that exactly mean when it's already so hot? It probably just means a series of very hot days, more of those, and fewer but more intense cyclones. Climate variability, El Nino Southern Oscillation is the main one that influences the wet tropics, and we do have forecasts for that information. Thank you.
Thanks so much, Chelsea. That's fantastic.
Yeah. Sorry, I kind of rushed through a bit, but hopefully there'll be some questions.
Yeah, so I'll open up to questions. And before I do, just to thank you for that. I thought it was really helpful to know what is out there, especially on the Balm. I can see that Emily has a question. Do you want to turn your camera on, Emma, and ask that now? How you going?
Hi. Thank you for that. I obsessively watch the weather as a water quality sampler, so I need to know when it's going to rain and preferably how much it's going to rain with a bit of notice, so we can go out and capture those stream flow events. One thing that I've been recommended to watch, but I just haven't got my head around, is the Madeline-Julian oscillation and how that can affect tropical rainfall. Like I've noticed a trend where if we have high rainfall predicted and the Madeline-Julian oscillation is in the area, it tends to fall on that higher end rather than like the median. But Yeah, I've also noticed that sometimes the Indian dipole plays a part in how extreme those events can be. And I'm just wondering how you figure out the way those, like, I guess, shorter term climate drivers interact.
Yeah, great question. A lot going on there.
Yeah.
I love it. Yeah, so essentially the computer models that the Balm uses to generate all of this stuff take everything into account. So it's not just the El Nino Southern Oscillation and, you know, whatever. It's what's the MJO doing, and what's the Indian Ocean doing, and what's the Pacific Ocean doing, and actually how much sea ice is there, interestingly enough. All these different things go into these seasonal climate models. I like to do as you've done, and like if I see that there's a forecast for some rain in an area that's impacted by the Madden-Julian Oscillation or the MJO, just makes it simpler.
Mhm.
I'll go look and be like, oh, what's the MJO doing? Is it active in a phase that tends to bring rainfall to that area? Or is it, you know, projected to be? And if it is, then I'm like, okay, so part of this rainfall is probably coming along with that Madden-Julian Oscillation. So therefore I'll trust that forecast a little bit more. Or as you pointed out, you know, maybe it tends to bring higher rainfall totals. Or it's more likely, you're more likely to have higher rainfall totals. But the weather forecast as well will incorporate all that information.
Okay.
It just, for me, it helps with the why. Or like, can I trust that forecast, or what's kind of going on here? That's why I look at those things. And yeah, so, and including the Indian Ocean dipole. So generally, I couldn't find a huge amount of influence of the IOD into the wet tropics. It tends to kind of go more from the Pilbara Gascoyne area and stretch down to maybe hitting kind of southern Queensland a little bit. And then the other interesting thing about the Indian Ocean dipole is it's only active from August to December. As soon as the monsoon starts, it blows out the Indian Ocean dipole. That doesn't mean that there isn't some connection between the Indian Ocean and your rainfall, but it would exist outside of the Indian Ocean dipole.
Alright, so the MJO, I guess, is the one I should be watching rather than the other.
Yeah.
Yeah.
I mean, you might find some like random connection through, you know, but it might just be a statistical anomaly. Like there's no data showing that there is a connection, but the MJO definitely.
Okay, cool. That's good to know. Thank you.
Yep. Great question.
Any other questions at this time?
I do see one in the chat about the relationship between the Indian Ocean dipole and the Southern Oscillation Index. So if you want me to.
Yeah, I'll give that one a go.
Yeah, really interesting. Let's see if I can find a map. Actually, what I'll do. Well, anyway, so the Pacific Ocean and the Indian Ocean connect to each other through what's called the Indonesian through flow. And it's essentially water from the Pacific goes through all the islands of Indonesia and stuff, and kind of essentially drains into the Indian Ocean. That's sort of the connection between the two. And so when you have something like this really large La Nina event, what it's doing is it's pushing water, unusually warm water, because we have an increase in the trade winds blowing across the Pacific. So they're essentially pushing warm water that normally sits along the equator. They're pushing it closer to Australia. And that's why we've ended up with more rain this year. And all the forecasts have been quite wet. But it's also pushing that warm water through the Indonesian through flow. And so the result is that when we have warm water sitting off sort of the eastern part of Indonesia, that'll have come through the Indonesian through flow. When we have unusually warm water there, what usually tends to happen is that you get unusually cold water off the Horn of Africa. And that's what's called an Indian Ocean dipole negative event. We tend to like those. It's the positive ones that dry us out. And yeah, so that's essentially the connection. So it's not necessarily a connection between the Southern Oscillation Index and the Indian Ocean dipole, because the Southern Oscillation Index is just a measure of pressure between Tahiti and Darwin. And that essentially tells us what our atmosphere is doing. Probably the more obvious connection there. I mean, there would be an atmospheric connection, but the really obvious connection is that water from the Pacific, especially when the trade winds strengthen, like during a La Nina, pushing that warm water through and gives a greater chance for an Indian Ocean dipole negative event.
Great, thanks, Chelsea. I've got a different kind of question about so the tools that showed us today, those Outlook tools. What kind of feedback have you had from land managers and agriculturalists about those tools and how they can use them?
Yeah, that's a really good question. So I think lots of people are really excited to learn about the European Center forecast because it's arguably slightly more accurate than the Balm forecast, arguably, but I mean it's like this much more accurate, not like this much. But people kind of got burned from the Balm quite a bit, so they're always interested in kind of looking at something else. However, what we find is that unless you're a real nerdy climate weathery kind of person, you're going to look at it once and be like, oh yeah, that's cool, I'll check that out again in the future, and then you don't. So what we've actually created is a little PDF climate calendar that essentially has hyperlinks, and every month it tells you which websites to check and why. And it just, that way you can just click on the link, you know, you take 5 minutes over your coffee in the morning and look at what's going to come. But generally, unless somebody's really nerdy, there are just way too many web tools out there and nobody has any time to look at them. So even if they're really helpful, there's quite low uptake, I'd say. So
the PDF you mentioned, is that somewhere easy to find?
No, not at all.
Okay,
we haven't published it on,
with people.
Yeah, we haven't published it on our website yet. It is available, and I'm happy to share it. Is it best just to send it to you, Sarah, or Monica, or?
Yeah, that'd be great, and we'll share it.
Yep.
And do other people have questions? Well,
I see Joe has his hand up.
Oh, sorry, I can't see that. So, Joe, sorry, Joe, and please turn your camera on so we can see you while you ask a question.
Yeah. One's a comment, one's a question. I'm just hop in and shut the door. I just in a tractor and someone just opened the door.
I love it that you're in the tractor asking the question, Joe.
I'm a cane farmer in the Wet Tropics.
Mm-hmm.
And like I said, one's a comment. The grower wears all the risk. These are very smart people that make all these climate forecasts and variability, but they don't wear any risk. Ultimately, it's the grower that wears the risk if it's right or wrong. That's one thing. And when these climate people say there's going to be above average or below average, we've got to be careful because the Queensland government is trying to legislate. I, as a cane farmer, can't fertilise within 48 hours of heavy rain.
Oh.
Last year they said September, October, November was going to be La Nina, above average rainfall. So in September, when we cut a block, it was half dry. So we tried to cut it and we bogged the paddock up. We went back in October, it hadn't rained and we didn't make a mess. But because someone said it was going to be above average rainfall for September, October, November, you make the decision to go and cut it. But then because you bogged it up, your nitrogen use efficiency falls through the floor because you've bogged the paddock up and it's not going to return like it should. So I'm the one that wears the risk, and I'm the one that gets into trouble if the climate forecasters get it wrong, not them.
Yeah.
How do you overcome that?
Yeah, it's a really interesting point. It absolutely drives me nuts. I sit in a lot of Balm meetings and they'll like review how the past few months have been, like was their forecast right or wrong? And usually they'll say something like, look, overall, yep, we were pretty spot on. You know, maybe this area is sort of southern Queensland and you know, maybe up by Innisfail, we didn't get it quite right, but overall over the whole country, we did really well. And I'm like, yeah, except for those people who are
that's my problem.
Yep, no, and I totally get that, and I see that, and you're absolutely right in saying that. I guess, you know, as producers of any crop, it's always, everything's a risk. You know, you might sell today and be based on some price estimate that you thought you had, and then the next day it goes up and you should have waited 5 days, but you didn't. Again, you know, we don't have that crystal ball that says this is exactly what's going to happen for the next season. So they made a seasonal prediction based on what the majority of the model said. And, you know, for your area, the majority of the models said it's going to be wet, and then turned out it wasn't wet. And like I said before, that happens. So 7 out of 10 years, it'll be right. 3 out of 10 years, it'll be wrong. And look,
and I can live with that, but I don't need the government to make it regulation that I got to follow that.
You and me both. Yeah, look, I if we ruled the world, we would absolutely get there.
We have a problem.
Yeah, and look, I didn't actually know about that fertilizer thing. I'm going to look into it because that's really interesting. And I feel like the government's trying to do the right thing, but as always, when they try to do the right thing, they create about 10 other problems in the process. But yeah, so look, you know, the other option is to not look at a forecast at all and make a decision without the use of a forecast, and that might work for you, you know. I don't have a good answer.
No, I know, and I'll give another example. And I know climate forecasting is not a short-term weather forecast. Friday, Saturday, Sunday, we were going to get 40 mils total, and we ended up with 1,000.
Wow.
So, you know, the government's saying on one hand, don't do this, but, you know, if you're going to get heavy rain, but 40 mils is not a problem. But to get 1,000, you know, but then it gets thrown back at cane growers or, you know, cane farmers that we've done the wrong thing.
Yeah.
So somehow we got to try and clarify. Yeah, I don't know how to do it, and I've said to the government they need to talk to the Weather Bureau or whoever, but they're all about their political agenda is to save the reef. It's not about the reef; it's about politics.
Of course,
it doesn't help. It doesn't help me.
Yeah, no, and I get that. And unfortunately, all I can offer is my sympathies. But I'm very happy that you shared your experience, and I'm going to look into that fertilizer thing because that's really interesting.
Yeah,
so thank you.
We can't fertilize within 48 hours of heavy rainfall.
Yeah, right.
Okay. Thanks,
Yeah,
Chelsea.
thank you.
Thanks, Joe. That's really great that you shared that experience. Super frustrating. And I wondered if you had actually, since you were speaking, if you had any feedback beside accuracy, which is obviously just something that the Bureau is constantly working on. Is there anything else that would help you in making some of those decisions?
Yeah, no, and that's where we need to be consulted, because sometimes, yeah, and you're right. If I want to go back and see how accurate the Balm forecast was, you got to pay money to find that out. I think you got to pay money, and everyone agrees that it's and look, it's better than it used to be, but yeah, when you're in the wet tropics, and I was hoping something today you could tell me was unique to the wet tropics that's different. Yeah, is it right 60% of the time, 50% of the time, or 80% of the time? And is there something in it? Because you look at the weather forecast and they'll tell you you're going to get 50 mils of rain at 2 o'clock this afternoon in Brisbane, Sydney, or Melbourne, and it happens. But it's not the same in the wet tropics.
And I think too, as producers, you have a lot more to lose. So we tend to notice when they get it wrong. But actually, I will show you something if you have a minute. Because you said,
Yep.
Oh, look about the skill and all this. So on this, so I'm back to the Balm website. And so interestingly enough, they've added these stars here to let you know how frequently this forecast has been right in the past. So for this forecast, it's actually been right in the past quite frequently. But they also have these skill maps, past accuracy. So you can see how frequently they've been right in the past. So like if if it's September to November and you're in Carnarvon or something, they haven't been right more than 50% of the time. So you wouldn't trust that forecast. You'd take one look at that and go, yeah, I'm not gonna. But then sometimes, over here, we're at 65 to 75% for September to November. And look, they still might get it wrong, but it's better than 50-50. I guess that's the point. I like to think about using forecasts as like betting on horses. So
that's why I don't bet on horses.
That's right. That's right.
Chelsea, one
Thanks,
thing that hasn't been raised, which I know is an issue across our regions is a number of weather stations. So the number of data points obviously varies across the country, and it's a lot better in the cities where there's a lot more weather stations. I imagine you don't necessarily have a lot to do in influencing that.
No, I wish. I hear it all the time, especially go talk to the poor buggers out in like you know, Eastern Western Australia or something. Like they really don't have a lot. But look, it has a lot to do with funding. Weather stations are really hard, really expensive to fund because they have to quality control them every year and also process all that data coming out. So I always say, well, hey, look, if you really want more weather stations, contact your local government representative and let them know that you're happy to pay more taxes to put towards the Balm's weather stations. And nobody seems to like that idea. But yeah, it's the fact of the matter is it's really having weather stations and maintaining that network and processing all the data is really expensive. I think in the future, and we're already kind of doing it, we'll go towards satellite rather than on the ground weather stations, because it's too hard to maintain.
Okay, no, that's good to hear that there's another
valid point.
option. Yeah. Are there any other burning questions? Because we're just past 4:30, and I really appreciate all the people who've stayed on to the end. Anyone want to put themselves up?
If not, please contact me. There's my email in the chat. If anything comes up in the future, reach out.
Thanks so much, Chelsea, for your time today. And just to let everybody know that this webinar will be on our YouTube channel and on our webpage, climate webpage, but also we'll have another one in October about a 101 on carbon farming with Louise Gavin. So look out for that one. And so thanks again to everyone who turned up today and listened in.
Yeah, thank you everybody so much. And thank you, Sarah, and everybody at Terrain for thinking of me and for the invitation.
Appreciate it. See you.
Thank you.